Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 5. We're continuing our discussion of trigonometry. And by this point, you're probably wondering, are we ever going to talk about trigonometry? Because now we are on Episode 5 and we still have not gotten to trig yet. Don't worry, it's coming. So, in the previous episode, we gave a basic introduction to angles. Now, what we want to do is think about angles in a new manner. So what we want to think about is let's go ahead and start with how we thought about angles in the previous video. So here is our circle and our XY axis here. We talked about how we want to think about angles as we start on at the positive x-axis and we move in a counterclockwise direction, and then that gives us a terminal side here, right? Now, when we look at this in closer detail, we can start thinking about this in a different manner. So, first thing I want to note is this quantity right here that I am turning red. So this is called an arc length. Okay, so it's the distance around, it's the distance that you travel along a circle's circumference. Okay, or you think just the length of this arc. If you boil that down, it's just how much of this arc have you traveled, which happens to lie on the circumference of the circle. Now, another thing we can note is our terminal side right here. This is a length of the radius of the circle, so I'm going to denote it with the R. And it's classical notation to use a theta for angle, so we're going to go ahead and do that after we fix our erasing goofs. So here is our angle, and we're denoting it with the Greek letter theta. So this equals theta, and theta always refers to angles. That's pretty much what that unit or that symbol always refers to as angle measures. Other common angle measures are the Greek letters alpha, beta, and gamma. So these are common angle, common variables for angle measurements. The most common will be theta, and sometimes I've also seen phi and rho. I can't really draw a rho because it's kind of like a slanted P, but RHO. So these are the common Greek letters for angles. Anyways, we're gonna pretty much be using theta for most of the videos. Now, what we're interested in is a discussion of how to measure theta, and how we want to do it is thinking about this in terms of arc length, interestingly enough. So if we start with the circumference of a circle, we know the circumference has to equal 2 pi r, based off of previous fun facts. So the circumference is directly proportional to the radius times this constant of 2 pi. Alright. Now, the idea then is when we look at this circumference, if we think of a ratio of the circumference to the radius, then that's going to be a constant quantity. Because if we have our circumference divided by our radius, notice you're going to get 2 pi times r divided by r. And so we're going to be getting units canceling out. So this quantity is going to be unitless, and you're just going to get some leftover value here. In this case, it's a 2 pi. Now, the claim's going to be this. For any angle, we can get a unitless quantity, kind of like what we did here with this 2 pi. And it won't matter what the radius is, because we can kind of see how the r's are going to be canceled out in the end here, as we have here. So in this case here, we're assuming that we're going around the circle one time. If we go around the circle one time, we know that the circumference is 2 pi r. Suppose we want to go halfway around the circle. So if I go halfway around the circle, I have a half times 2 pi times my radius, and if I divide it by r, so this is 1/2 of our circumference divided by r, notice the r's cancel out. In fact, this 2 and this half kill each other off, and that just leaves you with a pi. This is also a unitless quantity. If I were to go a quarter around the circle, so that's a quarter of the circumference. If I divide that by our ratio, or our r, not r, when we look at this ratio, that's going to be a fourth times our 2 pi r over r. And so 2 pi divided by 4 is the same thing as pi over 2. It doesn't matter what r is, it cancels out every time. And this gives us an idea of a new way of defining angle measures. These quantities here are unitless, which is a plus in comparison to degrees. We don't have to worry about units at all. And so let's see. So what these quantities are going to be that I just highlighted, those are called radians. Radians. So these are unitless angle measurements, if we can spell. And so that's our first point about radians. And radians are, we can think of as the ratio of the circumference divided by the radius. And we're going to denote radians with our theta, denoted by theta. So there's 3 basic points we can indicate right here and now. Alright, so let's go ahead and look at this. Well, before we look at it, we can note if this quantity that we highlighted is the circumference divided by the radius, then we want to think about modifying this to come up with our equation. So we'll come back to this point in a moment. We got to do a little bit more work. So here's our circle, and let's get a new color. Here is our theta. Here is our arc length right here. So when we had a so when we looked at these quantities here, we had a c over r, we had a half of our circumference over r, we had a quarter of our circumference over r. These quantities here, while they're amounts of the circumference, what are they really? Let's think about this for a moment. If I go all the way around the circle, right? So I'm going to use this in green. If I go all the way around the circle here, that is a arc length. It's an arc length equal to 2 pi times wherever the radius is. But if I go halfway around the circle, this arc length is going to be just half of whatever the circumference is. Similarly, if I go a quarter way around, then this arc length here in green is only going to be a quarter, right? So we could think of our angle here in terms of radians as the ratio of the arc length. So theta is going to equal the ratio of our arc length divided by r, where s is going to equal arc length. And this actually gives you a new equation. So if the angle here in terms of radians is s over r, then you know that arc length s has to equal r times theta, because we just have to multiply both sides by r. So there is a relationship between arc length and these angles. If you have theta times your radius of your circle, you will get what this arc length is. That is very convenient. Alright. Now, let's see what we got. So we got arc length. We first thought of it in terms of ratios as circumference over radius, but to generalize these results, we boxed them red. We had to say that it's more like the, well, not more like, but it is the ratio of arc length over radius. Alright. So, now we gotta talk about the relationship between radians and degrees. Alright. So, relationship, that needs to be a P, between, I'm just going to do DEG for degrees and rad for radians. In fact, this is normal notation here for radians, and if someone does give a unit, rad is for radians. And for my calculus students, I like to say you have to have your calculators in rad or your grade will be bad, because calculus only does their angles in terms of radians. So that's a nice fun fact for those of you that have not taken calculus but are interested in doing it. If you stick around through my videos, we will eventually get to calculus, which is super exciting. Can't wait for that. Well, I can. I have to wait pretty much through trig and some other fun stuff. Now, so the relationship between degrees and radians goes back to our circle here. So a circle, if we go one full rotation around, that's 360 degrees. Well, 360 degrees is going to be the same as, if we go around the circle in terms of radians, that's going to be an arc length. You think arc length would equal 2 pi r, but has to be divided by r, right? So arc length over r, which is our theta, has to be s over r, which is 2 pi r divided by r, which is 2 pi. Alright. So that means 360 degrees is going to equal 2 pi rad, if you wanted to write this out, but it's technically not a unit, but it is still rad, and I like being rad because it's radical, but not in that radical meaning. All these math puns, delicious. Now, if we go halfway around a circle, we know that that is going to be 180 degrees, or we just think pi rad. And this here is going to be our fun fact that we want to focus on for doing conversions between radians and degrees. So, if we're given, for example, I don't know, 272 degrees, what we can do is think about this equality here. If we want to convert from degrees to radians, then we can think if we were to divide both sides here by 180 degrees, this tells you that 1 degree is going to equal pi over 180 rad, right? So in other words, what I have to do is multiply by pi over 180 degrees, and that's going to give me a quantity that's in terms of radians. So what I'm going to do is try my calculator here. Do 272 divided by 80. And I'm going to hit math and see this button here for frac, hit enter, and there is my reduced fraction. So 68 over 45 pi. Notice it's exact value, no decimals. So if I multiply this by pi, we can see what the decimal looks like. If I was your math teacher, I would be marking you down wrong for giving me this as an answer, because this is the answer. This is a approximation. If you give me like something like 4.747, yeah, that's an approximation. This is the exact answer. So this, what we did is converted 272 degrees, and this is its value in terms of radians. Pretty cool. And if, say, for example, I had, how about 21 over 7 pi rad? We want to figure out what this is in terms of degrees. Well, we can think of this equality in the following manner. 1 rad has to equal 180 degrees over pi, right? So if we divide both sides by pi, that's going to tell us how to handle this. So we're going to multiply this by 180 degrees per pi rad, and that's going to cancel these out. So then we get 21 times 180 over 7. Let's figure out what that is. 21 divided by 7 times 180. And let's convert this. Cool. Oh, I should have realized that. 21 over 7 is 3. That's my bad. That's pretty funny, actually. That's what you get for doing math videos late at night. So this is 540 degrees. Alright. I guess we need to pick a better example next time, like 11 for our denominator. Alright. Now, one thing you may be wondering is, in our previous video we talked about coterminal angles. And so let's go ahead and extend our idea of coterminal angles. So if I have, say, how about 21 over 11 pi? And if I want to find a angle that's coterminal to this, we can find like a positive one and a negative one. So 21 over 11 pi, huh? What quadrant would we be in? So I think it's going to be over here somewhere. Let's find out. 21 divided by 11 times pi. Yeah. So 21/11 over pi is going to be somewhere over here. We'll talk more about how I know that later. But for now we can just note that 2 pi is approximately 6.24. And this is pretty much 6 right here, so you know it has to be rather close to over here. Now, what we want to think about is, if I go around the circle to right here, that's 21 over 11, it's pi. Now, if I want to find a coterminal angle, I have to go an additional 2 pi around. So to find a coterminal angle, I can just simply add 2 pi. But to add 2 pi correctly, I need to get a common denominator now, so I'm going to multiply by 11 over 11. So what we get is 22, we get 20. So we have our 21/11 pi plus, now we got 22 over 11 pi. So when we add that together, that's going to give us 43 over 11 pi. Alright, so notice what we did here. In order to find a coterminal angle, we just simply added a multiple of 2 pi. And we can go the other way, right? We can take our 21 pi over 11 and subtract 2 pi. And we still have to multiply our 2 pi by 11, but the same principle. So we have 21 pi over 11 minus 22 pi over 11, giving us a negative pi over 11. So 43 pi over 11, negative pi over 11, these are both coterminal with our original angle of 21 pi over 11. Alright, with that, we're going to call it a day. So we can summarize. We have our fun fact right here. Pi radians is equal to 180 degrees, and we can interpret it in these two manners here in order to do our unit conversions. We extended our idea of coterminal to include radians, and let's see here, we thought about radians as a unitless angle measure because it's a ratio of arc length. Let's scribble. Arc length divided by radius, which means that whatever unit the arc length and radius are measured in, that gets canceled out, which is why theta is unitless. And we also noted that arc length is going to equal s will equal r times theta. So it's a pretty straightforward computation figuring out what arc length itself is. Alright. If you have enjoyed our videos, please consider subscribing, supporting us on Patreon. Thank you for watching and joining our math party, and I will see you next time.